Hi everyone, welcome back again. Now the big one. I leave this to last on purpose. The reason I leave it to last is people have trouble with the equation solving that's in the middle of it. Not the trouble with the trigonometry, but there is one very, very common thing that does happen. People put the x in the wrong place. And even though they know where to put it, they can still just put it in the wrong place. It's like their brain thinks that you always have to put the x on the numerator. On these questions we won't have the x on the numerator, won't have it on the top, we'll have it on the bottom. So it's trying to get a switch in your brain that is not on the top this time, it's on the bottom. Now let's have a look at it. Shortcut the whole process. Looking across from mini-me, there's the opposite. I'm going to do all three at once. Looking across from mini-me, there's the opposite. Looking across from mini-me, there's no opposite. Look at the hypotenuse, that's got something written on the hypotenuse. This doesn't have something written on the hypotenuse. And this one should have had an x written on the hypotenuse. I still prefer to say the easiest of those three is when you got the two things written with the right angle. We know it's a tan question, so tan theta is opposite on. So tan theta is the numerator on the denominator, the top on the bottom, O and A. Go over to this question. We've got an O and a H, so there's the O and the H. So this question is a sine. So the sine of theta equals O and H. Once you get used to it, you don't even have to write the rule down, but you might have a teacher insist on it. If they do, they're doing it for your best intentions, for their best intentions, for your best purposes. Let's have a look at that one. And then this one over here, I've got this time and next to that, that's the hypotenuse, so this one has to be the adjacent. Which one has the A and the H? There's the A and the H, so it's a cos. So cos theta equals A and H. Now if you practice it well, you can't really shortcut the process. Let's write the numbers in. This time I know the angle is 61 degrees. I know that the opposite is an 8 and the hypotenuse is an x. This one, I know it's tan. I know the angle's 41. I know the opposite is a 6. And watch again, because it's there, next to that, the adjacent, the x goes on the denominator on the bottom. Many people, I've seen it so many times, it's crazy, will write this as x over 6. I won't know why they've got it wrong. This one here, the angle is 52 degrees. The adjacent is 14. And the hypotenuse gets the x. Again, the x didn't go on the numerator, the x went on the denominator. Now, there's two approaches to teaching this. One is to thoroughly go through it, teach you about equations and show you how to do it. Say I've done that, I get a lot of people still get mixed up and it takes a while, have to go back and revise it, hold up flashcards. Even then people will still mix it up. So let's have a look. There is a rule. If the x, or I call it the rule, this is me. If the x is on the bottom, we can swap places. And some people don't take this in, so we'll go through another method in a minute. You might turn the video off in a second and go, I've got it, I don't need to watch the rest of this video. I can go to the next one. So, the bottom, if x is on the bottom, we swap places. I'd like to make up a fun tune or something about it. I haven't thought of one as yet. Once it's on the bottom, we swap places. What swaps places? I didn't say turn the fraction upside down. It's got to swap with something. Can't swap with the x. It can't swap with a 61 because that's stuck inside the sign. But it can go over here and replace the sign. So watch what's going to happen. That goes over to here. Then you've still got the 8 written there, and then that comes back over to here. And they swap places. Some people don't like me teaching that, you just, here's what you do, but what do you do when you just can't get it and it doesn't make sense? The interesting part was when you learn something like this and it sinks into your brain, it's like we talk about the penny dropped. It means that suddenly the lights go on. Suddenly in a week or 2 weeks, sometimes in a year or 2 years, maybe even 5 years later, that your brain goes, I've got it. Why didn't I understand that before? Often I say to students 1 year later, it's interesting 1 year later what happens. What you thought was hard the year before suddenly is easier. Couple of reasons, probably the biggest reason is your brain's more mature. You've had time for your reasoning to develop, maybe the electrical circuits or whatever it is in our brain has developed. You're older and your brain can take it in. I've known so many people who didn't do good at maths at school and end up, I know one lady become a maths teacher later on in life, and she looks back at it and goes, I was terrible at maths at school. I have another friend too that was terrible at maths at school, went to high level university, now highly qualified, but years later. He actually said to me the switch went on. One day the switch just went on. So that's just memorising, swap places. So I could come over to this one, I can just go X is on the bottom, swap places, X is on the bottom, swap places. So it will swap with all of that. It can't swap with a 6, it can't swap with a 41. So that's an X, and then that swaps over to there. Last one, X is on the denominator, X is on the bottom, X is on the bottom, swap places. I feel like something like XB, SP or something. Bottom swaps places, I can't think of something. Message me on the comments if you think of something that's really good for it, or better words. So the X comes over to here, and the 14 stays there, and the cos goes down to the bottom there. What do we do to get the answer? Pick up your calculator. So really we're finished, but I need to do it just for a second. Make sure your calculator's set on degrees. Make sure that we're not thinking we're in France. Make sure we're not doing radians, which is in Australia it's for the methods course, uses radians, and the specialist course uses radians. If you're in New South Wales, the methods course is called advanced, and if you're in specialist, it goes into 2 courses, and it goes into what's called extension 1 and extension 2. Extension 1's like for us here now in Western Australia, it's like a halfway to a specialist. So here we go. You type the 8. Remember, a fraction is the divide by. So many people still mess that up. 8 divided by, and we want the sine of 61, so I go sine 61, and I press equals, and it tells me that the length of that hypotenuse is 9.147. If I round it out, 9.147, and that was centimetres, that's centimetres. So we want the calculator to tell us the answer. When it's written like that, the equation doesn't tell us the answer. When it's written like that, the calculator does tell us the answer. And the answer is 9.147. I used to put centimetres, and we used to have to write when I was a child 3dp, which means you've used 3 decimal places. Sometimes people will use 2, sometimes they'll use 1. Just be careful which one you use. So we've got a 6 divided by 1041. And by the way, I didn't have to clear the calculator in between. The calculator automatically says, no, you're doing the next answer. 6.902. If that was centimetres, that would be centimetres. Old school, I put 3dp. This one here, 14 divided by cos 52. Cos 52. And this one I get 22. Let's see if that makes sense. 22.740. That's an unusual one. I'm not going to go into rounding the centimetres. So that's about 23 centimetres. So you can see here, this is a little bit longer than the pen. It's a lot longer than that was. It's not twice as long. If it was twice as long, it would be 28. So this one here was that long. You can go across there. That's not twice as long. So I want an answer somewhere between 14 and twice as long. So that's a pretty good answer when you do that. Now, please, if you're happy with that, switch off. If not, I'm going to teach you what to do on this one here. Need a bit of space, I'll get rid of this and teach the equations properly. So every time I teach this topic, there's always someone that says, can you show me properly? And of course I go back and show them properly, and maybe show them a couple of times properly. Let's have a look at this one, let's get rid of that as well. Not the hard way. The good part is if you learn this method, it actually gets easy. But first of all, you've got to learn the method. There's 2 ways to teach it, and I'm a bit torn still after teaching for a million years. Feels like a million years. So if I times this side by x, I think this is the best. We times that side by x. For some of you, one will work better than the other. I could show you both and you can make a choice. How do I get rid of a denominator? How do I get rid of a fraction? You've got to balance the equation up. If I double this side, I've got to double that side. If I triple this side, I've got to triple this side. Like a set of scales that are balancing up, or a seesaw. So I don't have a number though. That's what mucks people's brains up. If I get rid of that, if that was 3, I'd times by 3. If it was 10, I'd times by 10, times by 10. If it was 2, I'd times by 2, times by 2. What happens with a numerator and a denominator the same? I went to cross them out. How many times does x go into x? Remember, that's the top and that's the bottom. X goes into x once. So we've got 1 lot of 6. And over here I've got x tan 41. So it feels like a long method, but once you get used to it, it's so easy. What's between the x and the tan is that multiplication. What's the opposites of multiplication? I call them obs, which is the opposites. So what do I mean by opposites? We want the letter, that letter written by itself on the left, it's not by itself. It's married to the tan by multiplication. How do we undo that multiplication? By doing the opposite. And the opposite of multiplication is divide. So the opposite of multiply is divide, the opposite of add is subtract, the opposite of square root is square, and we go on and on about the opposites. So the opposite of timesing by tan 41 is divide by tan 41. And then it says the opposites to both sides. So if I divide this side by tan 41, I divide that side by tan 41, then how many times does tan 41 go into tan 41? Whatever that number is will be the same as that number. So any number divided by itself is 1. So I can literally just cross that off, and we don't have to write the 1x. So that would be 1x. So I'm just going to write x, then I pick up my calculator and I get the same answer as before. So I go 6 divided by tan 41, and I get 6.902, same answer as before. Let's have a look at what happened. We're about to explain here again. Here the x was on the right hand side denominator. It ended up on the left hand side by itself next to the equal sign. On the right of the equal side, on the bottom, ended up on the left. Tan 41 was on the left, ended up on the right hand side on the bottom. So those two simply swap places. So I can remember I went through this process and did that many times, and then one day I just stopped doing that and started swapping places. There's one more video to go. All we need to do now is give you a chance to make sure you've taken it all in. I don't know when I'll do that, but sometimes you'll get a chance to take it all in and I'll do a mixture of them. Thanks.